Hello everyone. In this video, we're going to cover math and unit skills that you're going to be using for our chemistry class this year. The first thing we're going to talk about is algebra. So algebra is where you solve for a missing variable in an equation. That's where you're solving for x. Sometimes there are multiple variables in an equation. You will be given some to plug in and will solve for the remaining variable. This is what we do in chemistry all the time. So here's some very simple examples that you may see and you'll practice today in class. If x equals 4 and y equals 2, solve for z. So notice we have three different variables. We have x, y, and z. In this particular example, they gave us the numerical values for x and y, but we don't know z, so that's what we're actually solving for. So let's plug that in for these two equations. So if x plus y equals z, and x is 4, and y is 2, what would z be? Z would be 6, because 4 plus 2 equals 6. That's a very easy example, but we're learning here. So let's try the other one. Let's say we have z divided by x equals y. Now it's a little harder. X would be 4, and y would be 2. Now I have to solve for z. Now with algebra, in order to solve for something, it has to be by itself on one side, the variable does. Just like over here, z was by itself, so we could just do the math over here to solve for it. Instead, z is not by itself, and rather we got to isolate it to solve for it. So what I'm going to do, since z is being divided by 4, I am going to move the 4 to the other side by doing the opposite function. Since it's being divided, I'm going to multiply both sides by 4. When you multiply and divide by 4 on the same side, they will cancel each other. So now, z just equals 2 times 4. So z equals 8. And that's algebra. This is the most math that you'll have to do. It's multiply, divide, add, subtract. You just have to sometimes move the variables around to actually solve for it. You have to isolate those variables. Okay, the next topic we're going to talk about is scientific notation. In science and definitely in chemistry, we deal often with very large or very small numbers. It gets really annoying to write this large number or this really tiny number, and it's even more annoying trying to say them. Scientific notation helps us write these numbers simply and easily. So we're just going to go dive into it. We got scientific notation explanation here. Exponents. 10 is a great number to use with exponents. So remember, an exponent would be something right here or right here. Whenever we do a 10 raised to the 6th power, or 10 with this housetop to the 6th power, what it's saying is it takes that 10 to the power of 6. It means it takes 10 and multiplies it by itself 10 or 6 times. 10 to the 6 is a 1 with 6 zeros. So this right here, this number, is the same thing as 10 to the 6th power. And 10 to the 6 is a lot easier than to write 1 million right here. When we multiply a number by 10 raised to a number, it just moves the decimal. So if we have 3.21 times 10 to the 4th, all we're going to do is we're going to take that 3.24 and move that decimal 4 spots to the right, and then we'll fill in some zeros. So 3.21 times 10 to the 4th is 32,400. Or 100. Oh, my bad, 100, because it's a 1 right here. Okay. When we have a negative exponent, though, a negative exponent, like here, Then we know that it is a small number, it is a decimal, and we have to make a tiny number. So if we have, like this example, 9.29 times 10 to the negative third, I'm going to move the decimal 3 spots to the left, and that would give us this tiny number right there. Okay, and that's scientific notation. You'll get some practice making scientific notation like this, like this rather, and reading it. Okay, this is just a quick note on calculators. Calculators are great. You're allowed to use them in our class, but if you don't use it correctly, it will spit out wrong answers. The biggest mistake we see is often students will want to do something like this, but they get the wrong answer because the calculator will first do this function, the division, and then it will add the 32 to it. So whatever you want the calculator to do, you just got to make sure you do it the correct way. If you want this to happen first, you got to put it in parentheses. So be very aware of the parenthesis use in your calculator. Oh, calculators have a very cool function that allows you to do scientific notation very easily. There's a function, and it's right here. It's a double E. Some calculators require you to hit this second function before hitting this button to get that double E. So let's practice using that. Let's say I had a number like 4.5 times 10 in the negative third. If I want to plug that in my calculator, the first thing I'll do is 4.54, using those numbers right here. And then I got to use my double E function. So then I'll go second, this button to put in my double E. And then finally, I want to put a -3, but a lot of people want to use this button. That's not the correct button you want to use on most of your calculators. That's the subtraction button. You want to use this button. That makes it negative, and then once again, we'll hit that 3. Okay, and that's just a little quick, helpful way to write scientific notation in your calculator. We'll get some practice. If you need help, just talk to Mr. Steppiner and we will help you. Okay, another thing we want to cover today is our units. Units are a form of measurement, or rather, it's just a unit of measurement. So we have different types of measurements like distance, mass, volume, temperature. In our class, those units to measure it are going to be, for distance, centimeters, meters, kilometers. Those are our measurements of distance. For mass, we're going to use grams and kilograms. For volume, we will use liters and milliliters. And for temperature, we're going to use Celsius and maybe some Fahrenheit, just a little bit Fahrenheit. Most likely not too much Fahrenheit. Mostly we're going to be using Celsius. So this is more of a heads up of the types of units we'll see. Now the units you're probably familiar with for like mass is pounds. For distance, it's feet and inches and miles. For volume, we've used gallons and cups, okay? And temperature, we use Fahrenheit. In this class, we're not going to use those. We're going to be using these units over here. Okay. Another important aspect of the class that you're going to have is unit conversions. Unit conversions is using ratios to go from one unit to another. For example, there are 12 inches in 1 foot. Now, I know we won't use inches and feet in this class, but we're going to use this as an example since you're very familiar with it. How many feet are in 48 inches? Well, if there are 12 inches in 1 foot, then there must be 4 feet in order to make 48 inches, because for every one of these feet, there are 12 inches. So that's an example of a conversion factor. We're going to teach you some tricks on how to do that, but right now you'll be practicing that in class. All right, that was a very quick little video for those of us that missed class or for those of us that need a little extra help.